they're hearing me too. We are on live in YouTube. Yeah. After I will tweet the URL, and I hope that some more people that couldn't come today could watch this. Welcome to Start Meetup. Who is the? I recognize lots of your faces. Who's the first time you're here? Wow. Okay. Maybe I saw it some other meetup. Well, we are a meetup talking about Apache Spark. That was a bit the picture how the meetups were, the Spark meetups were in last year, March of 2016, and that's how it looks today. We have lots of competitions here, but well, it's cool to see that the community is growing and that the technology is getting more and more mainstream, I would say, because last year was, well, we didn't even arrive at 2.0, right? It was just last year. Well, I don't remember. But well, for our case, we grow. We are almost 1,900 members. And a bit from you today, we all normally do a poll like that to see how is your knowledge before you come to the meetup, to see if we need to do more complicated or less complicated talks. There's lots of variety, as we can see. I hope that the ones that know less from it could teach the ones that don't know it. We are live on YouTube. It's the second time that we're doing it right now. The other time was with Holden Carao at the end of last year. And we are thanking Trovit for the venue and the networking session that we're doing downstairs with beers and pizzas, where after all these speakers will have presented in a short period of time, we could discuss a bit more about their problems or what they're proposing. Let's start with PeopleOps. Trovit will present a bit.
Hello, everyone.
Wait a bit.
There's a presentation, yes.
Wait. Where's the Trovit?
I'm nervous. It's my second time. So the second time that I introduce a meetup as the leader of the PeopleOps.
Christian, I got a problem.
He's gonna solve. I don't have a problem. He has a problem.
I got a problem.
Nice.
Wait.
Where is my presentation?
Where's your presentation? That's the thing. Wait.
The world is watching. I'm waiting.
Yes, the world.
I'm being streamed.
All in front of the window.
I'm still nervous. Sorry about that. Just trying to be funny because I'm nervous. My boss is here watching me. He didn't tell me he was coming. And well, basically, there is a presentation. Hopefully, it will come up at some point, but it's just a few slides. As I said, I am.
No.
Well, I told. Can you?
That's when you have to type your password.
Make course,
Invitation to view. You have it over here. This is my presentation. Go for it. Come on.
That's. But you sent it to me, right?
Did you see the email?
Wait.
Let me find it.
It was in the email.
Yeah.
Let me find it for you. And
Oh yeah. Thank you, Christian. That's it.
This is just for the
Sorry
live,
about. Yeah, that's the 5 minutes I got.
yeah, that was my presentation.
Looking at the presentation from.
No,
Okay,
sorry
so-
about that. Let me just go through it very quickly. It's very short, really, but this is the fee that you have to pay before talking about Spark. And this fee is, listening to me talking about Trovit and why Trovit is a very cool place as an organization. Not only because we do Spark, but many other things. So, just grab the presenter. All right. So, first of all, thanks for coming. Hope you enjoy it. Before I go into my topics, a little bit of housekeeping. It's 7:10, so it probably won't be at 8, but well, As soon as you finish, the beers and the pizza will be ready at the kitchen downstairs. So hope you enjoy it because I'm preparing all of that. I cooked all the pizzas. True story. Now, very shortly about Trovit. Who knows Trovit? Okay, I'll do it quickly. Well, Trovit employees don't count. Don't raise your hands. We are what we do is a classified ads search engine. When you read it like this, it's not super sexy, right? Now, this is more sexy. We operate in no less than 51 countries in the 4 verticals that we work on: real estate, cars, jobs, and products. That's a lot. And I guess that has a lot to do with the fact that we use Spark. And yes, we had this little token on our website saying that we are a great place to work. 6 years, and it's actually 7, but it will be announced in a few weeks. What else about Trovit? Does that make us a very cool place? Well, perhaps, but again, those texts were not so sexy. This is sexy. This is essentially what we do. We help a good number of millions of people right at the moment when they're making really important decisions in their lives. When they're changing cars, when they're buying or looking for rent, place to live, when they're trying to find a job, or when they're trying to find anything that's on the internet, any product on the internet. So really, really important in their life. We help them. And that's more powerful than just being a search engine or classified search engine. This is what we do, and this is what we're passionate about. We make it simple, or we try to make it simple, and obviously quick and easy. Again, houses, cars, jobs, products. I emphasize jobs because I need people operations, so that's my thing. What else about Trovit? Beyond the beers and the pizzas that I cooked. Remember, this is what we do. We're not a search engine. We help people. And hopefully, today, thanks to the speakers, we will help a few of you in getting more knowledgeable on Spark. Thank you very much. Thank you, Christian.
I didn't even have time to tweet about the live stream, but I'm almost done. So our first speaker, and let me finish with the presentation I had here. Present. Well, now we're going to with the talks. Before, I want to announce you, even if it's not really official, these guys, Stratio from Madrid, they are interested in coming to tell some things about Spark Streaming and MLlib, I think. So probably you'll receive an announcement to the creation of the next meetup. I don't know when will it be, but I think it will be. It's so interesting. Then we're having our speed talks. It's something that we never tried, and we're a bit excited about it. We're excited that we got six proposals, and the subjects are quite different. The topics are quite different, so I think it will be interesting. Each of you, you'll have 5 minutes. I'll try to chrono it. I got some papers to show the timeout and different things. And 2 minutes for questions and answers. After it, we can discuss the rest of it at the kitchen. So that's it on my side. And we're welcoming Miguel Perez, that he will talk us about extending Spark Datasets API, right? Data source. Nice. So before starting the chrono, you can start speaking. Here we go.
Okay, I'm the first one, so let's see what happens. We have just 5 minutes to talk about what data source in Spark is, and know or start with knowing how to implement a simple one. So if you have some knowledge, you're not zero in the punctuation of the meetup. You probably will know this line. Spark read format. Format is string, and then we load a path, and this returns a data frame. So we're going to see what is Spark doing when you execute that line, and how to extend the API to have a custom format. For example, format is JSON or comma-separated values. But imagine you have a custom format you're using, and you want to read and write it back. So we start with Spark session or SQL context here before Spark 2.0. And the read just returns a class called DataFrameReader. Then you call format. This, remember, is just a string, and format is just a setup. So the magic happens in the load method. Inside the load method, you end up in this method called base relation to data frame. That's calls the data source object and calls resolve relation. Inside the apply, you just pass your format name, and this knows how to get the data source. So at this point, you probably are asking what is a base relation. Simplifying it a lot, base relation is just a class that knows your schema and how to read your data. In the documentations, they say that it implements a scan trait. So let's see. Spark needs now to resolve our relation. So inside the load method, it will have a lazy value called providing class. Okay, so remember, format is a string, and probably you've seen that sometimes it's a short name like JSON, and others is a fully qualified name, and maybe it's a package name. So Spark, in order, will try to load the first one. To do that, you have to simply implement the trait data source register, which defines a get short name. So, for example, the JSON is implementing this class and defining the short name as JSON. You can have also the fully qualified name, which uses a class loader, or the package name. In this last case, Spark assumes your class is called default source. At this point, we know the class of our data source, but Spark doesn't type check anything. So we have our class, and then our class needs to provide the relations, as we said. So at this point, we have two options. We have to implement one of these two traits. One is schema relation provider, which needs a user-defined schema, and relation provider, which will get the data and try to infer the schema. Both of them have a create relation method, which get a SQL context params and returns a base relation. So our relation knows its schema, and this is implementing a base relation. The schema can be get manually or inferred from the data. And then we have table scan, which is one of the scan traits that implements a build scan, which returns an RDT of rows, which will get translated to the data frame. So that's it for reading. If we want to write the data back, it's similar to reading, but you are getting a data frame writer, and you have to implement your data source for a table relation provider. Well, the method gets a safe mode and a data frame. That's it.
2 minutes of questions.
Wait, one question for me. This is just for the format of the file, but you still read everything from HDFS, right? Or from any kind of standard data source. It's just like the format of the file.
Yeah, it's the format. When you're loading the data, for example, you have access to the SQL context. So you can do SQL context that Spark context that text file, and this will get you the file from HDFS or local file.
Oh, wait, that's okay.
Then you just have to translate the RDD of strings to your schema.
Can you tell us about a situation where this might come handy?
Well, I have an implementation of comma-separated values. But for example, you have text files or any binary files, for example, keep it simple. And you have custom formatting. Imagine you are separating values by a point instead of a comma. Instead of reading the files and doing a mapping, and the same for writing, but you just implement this. It's a simple one is just 50 lines of code. So
just an appointment. For example, if you are working with blockchains, Bitcoin and Ethereum save the files in a special format, a Merkle tree root. So you need something like that to read and write.
Perfect. Thank you, Miguel. Okay, since this thing was Cesare's idea, he had to do one, so he couldn't escape.
that was
He's
kindly asked.
talking. I think it works. Yeah. Well, you can present yourself.
Yeah.
I'm gonna start your timer.
No, so last time because I took out my presentation. Okay, so I'm Cesare Cugnaska, one of the two organizers of the meetup, and I work in BSC. So actually, very lucky that I made my presentation after this one, because my idea is to get idea how to make a data source, so you can get some idea from your presentation. But there will be some different because we have a different system, and we want to connect our system to Spark. So I know that Spark with QB is the approximate multidimensional queries. It is not the easiest title you can imagine, and okay, I get it. So we start from motivation. Why multidimensional indexes? So basically, I will give you two motivations. We work in HPC. Usually in HPC works, we have a supercomputer. You book some computers, you wait to run a simulation for many hours. Then when you finished, you book another supercomputer that have a lot of GPUs. You make another reservation, we wait other hours to make the data look something you can understand. Then you load everything in something so you can visualize, and then you realize there was a mistake, and you go back and you do everything again. And this can take 1 month or even more. So the idea would be to be able to reduce all these three phases in one. Not that easy, just some, but this is the idea. And I will tell you why multidimensional indexes is the way to do it. Then another application is three-dimensional analytics. There are many data that says intrinsic multidimensional. For example, a use case we are working in the Human Brain Project is they're trying to making some MRI images of neurons in the brain. Each of the images is like 20 gigabytes,
we want to recognize the cell in these images, and then we want to create an atlas of all this brain. The point is, the images are big, so if you want to work on attributes, you have to split them. But once you split them, you have also to reconstruct the data you detect. So we have to make some indexed query on the boundaries of the images. And also, those are just splits of an image, sort of a brain. Actually, they told us it's just like a slice of a brain. So it was actually disgusting to see the images. But then in the end you have many slices, and you want to merge what you detected in an image to another. So this is another multidimensional query, because you have to try to merge the results that you have in different simulation and different data. So what they have in common is two analysis. They basically, in the background, they do something similar to this query. So they are basically filtering for in a multidimensional space. And also, what we saw that was happening many times, the algorithm needs only a data sample. They don't need all the data, but they can work also with a partition of the data. The point is, if you don't have any index, to do this kind of query, you have to read all the data and then filter in memory. It means that if you read 1,000 elements, but your data set is 1 tera, you need to read teras of data. So, this is why there are multidimensional indexes. And the problem is that it is not easy to make them distributed in multiple nodes. So I won't enter into many details. Basically, the two approaches are: or you take the index and you recreate an index in any node, so you distribute the data random between these nodes, or you create a distributed index. The problem that's both approaches have some trouble. In the first case, you still have to send each query to each node. And then you have a limit in scalability, because the throughput will be limited to the single node. And in the second case, you will need to make many queries between one node and another, because you're distributing the data, so you have a high latency. And also you have this nice, this is also a pointer, these nice points that are hotspots. So this is why we developed the ETH tree. As basically the idea is to take Cassandra, to take the point that you can duplicate the data, and it's good for if you duplicate stuff, to make some sample of the data, to replicate it in a way that we can navigate in the index without having to pass through all the data. We'll go very fast. So this is the way you create a QBIS, that is for multidimensional indexes. The point is, we want to integrate with Spark. And this was the part that I wanted some help. Because the part is, source integration is something maybe related to the previous talk, but then we have some additional feature. For example, filtering pushdown and integrating with the Catalyst Query Optimizer. The point is, if we want to create a data frame like this, when we do a query, I want to be able to do this query by accessing to the data within the index. And so we have to find a way to instruct Spark to say, okay, this kind of query, you can do it using the index. Other things you can't, so you have to read everything in memory filter. And the same things for the sample. Because even here we are doing a sample, and it would be great if we can avoid to do in memory. Okay, that's it. This was the last one. Question? Any question? I don't bite. Yeah, I know that you like the formula.
No questions? Thank you, Cesare.
Can you tell us more about filtering pushdown?
Yeah, basically this is something, it's already implemented in the Cassandra connector, and it works by understanding if filtering can be pushed down on the data source. But in our case, it will be much more complex, because we are not filtering just for one element. We can make more complex. It's more complex the criteria to decide whether to filter or not. And also with Catalyst, if you do a join or if you merge it, will depend on also the selectivity of the query to see if it is really worthy to make it. So this is kind of all black relational database magic that sometimes is also useful to distributed computing. But still, we will have to study it. That's it.
That's it.
Thank you.
Thank you. Now Mark Podina is presenting Pimp My Spark. I got it here. Yes.
So any of you know about implicit conversion and adding my library pattern? Okay, great. So we're going to the example. If we have a string in Scala, you can call lots of methods on it. Like you can call the hash code method or length, or if it's empty or not, and then even you can call the whoa.
Point it here. You can have to point here.
You can even call the toString method on it. But one thing that you cannot do is call the freeze method and get an ice cream.
I think you have to.
Not working. Now.
I press it. I think you have to press it because.
Yeah. Okay. So, and that's a shame. And that is when the implicit conversion would come handy, and it would look like this. And it works as follows. So you have a string, which is a very sad object because it doesn't know how to freeze itself and get and turn into an ice cream. And then you have to write a wrapper around this string that knows how to freeze a string and get an ice cream. And then the only thing that you need is an implicit way to get from one to the other. That's how the pattern works. It's not that hard. And okay, but what does this have to do with Spark? Right? So this is the pattern that most extending libraries in Spark use to add functionalities into Spark. And I'm going to explain a little example on how this works. So imagine that you are building a flirting algorithm to flirt with people using Spark. Not a good idea, just an example. So you have people, and then for each person you try to chat with him, and then if everything goes okay, you go to the next step, which is ask him out or her out, and then if everything goes okay, you try to please him or her, depending on. Okay. But at each step, everything can just broke and go completely wrong, and the function will just throw exceptions at you. Okay. And if you want to implement this with plain Spark, you would need to write the code, which is very ugly, and I'm going to show it to you. So you would just load persons from HDFS or from wherever you store persons. I'm not judging. And then for each step in your pipeline, you would need a code like this, which just maps each element to the function, and then it wraps it into a try. And then if you want the succeeds, you just filter them out, and if you want the failures, you just filter them out. But if you have a pipeline, for example, with 3 steps, like chat with somebody, then ask out, and so on, you would need this replicated 3 times. This doesn't scale. You cannot chain operations. This is not a good code to have in production. And moreover, if you like to have all the mistakes in one place, you would even have to write a union for all the failures in each step. Bad code. So let's see how the pattern would improve this code. What you really need is a Spark data structure that you could pass functions into it, and this structure would handle all the exceptions for you, and then at any given point, you would just ask for all the succeeds or all the failures, and it would give them to you back, right? So that's the code. A little intimidating maybe, but let's step through it, and you'll see that it's okay. The first thing is it's a class that extends RDD and has 2 parameters, one the parent RDD, and then a function that you pass through it, and it can throw exceptions or not, doesn't matter. And each time that you extend an RDD, you have to implement some methods. For example, the compute method, where it iterates over a single partition, and then for each element, it applies the function that you have passed here as a parameter. And if it encounters a failure, it just keeps the failure around for further use. Don't bother about partitions now. And these are the functions that we add to our RDD. Right? For example, attempt method is the one that you can pass a function into it, and then it will return a new gentle RTD, which is the class that we have done, and the gentle RTD will handle all the exceptions for you, right? And this is the implicit conversion from one type to the other. So how this can help us? Right, remember the code, the early code that I wrote? Okay, so with this new feature, we could change this, we could turn this code into this much nicer code, where you can just chain all the operations, and then at any given point, ask for all the subsets or all the triggers. And you can even do the same thing for datasets, or anything. You can implement any logic, really. And that's it. Questions or anything?
Yeah, one question. Because is there any limit between using this pimp pattern and not using it? Because I see many documentation on things that use pimp, but it is very complex sometimes to understand what an object does, because there are many things that are implicit.
Right.
So where do you?
Okay. With this is a philosophical question, right? I go the same way I would go about abstract classes, or extending a class. How do you know that you can call a toString to a new class that you've done, right? Because it implements object. And how do you know that it implements object? Because you know Java, and all these things. So once you know this pattern, you just put it in your head, and it's a possibility that
Something okay.
yeah. Okay. Thank you.
Thank you, Mark. So now it's time for Cisco Sastra. Cisco, I think Mark took the pointer. No, it's there.
You ran away with the pointer.
I'm gonna put your presentation here. Wait a minute. This one.
Hi everybody, I am Cisco Sastre. I work at BSC with Cesare, and I am working currently with TensorFlow. Now I am trying to distribute TensorFlow in the GPU cluster that we have there, the Minotauro cluster. And this presentation is for talk about how can Spark help. For those who don't know what is TensorFlow, TensorFlow is the machine library by Google. It was released in November 2015. It has a Python and C++ API, and it has GPU support with CUDA. It uses the graph computational paradigm, and of course it is open source, and the first stable version was released the last month. With TensorFlow, you can do the more basic things with machine learning, and it is more focused for deep learning. It has a lot of implemented things to the convolutional neural nets, LSTM nets, etc. Now I am going to talk about the distribution pipeline. Okay, first the distributed version with gRPC was at in the version 0.8 in November last year, and the HDFS support was at in the version 0.11 at the end of the year. Okay. First, I have to say that I'm not an expert with Spark, okay? And if I say something wrong in Spark, I'm sorry. Okay. TensorFlow has two different ways to distribute the training. For example, for the neural net, has the synchronous distribution and the asynchronous distribution. There are two types of processes: the worker process and the parameter server process. The main difference is the way to merge the information from the workers, and the synchronous way. The workers start to train the neural net, and then sends the information to the parameter servers. It can be one, or they can be 100. Okay. The parameter server waits for all the workers, and then they aggregate the information from the workers and creates a new model. This model is sent to all the workers, and the workers continue the train. In the synchronous parallelism, there is a main change. The workers send the information to the parameter servers, and then the parameter servers creates a new model immediately and send it to the worker. Okay, every time that the worker sends information, the parameter server creates a new model. It is faster, but if there is a worker, a slow worker, you can use bad data to create a model. If you can send a bad model to the workers that are working faster. Okay, there are some problems with the distribution. You have to change the parameters. You have to change the batch size of the data, or you have to adjust the learning rate. There are something that changes from the single training. Okay, there are the stateless in the synchronous way, and TensorFlow has some problems for creating a cluster, for manage a cluster. It's a mess, and there are some network bottlenecks because a model can be 600 megabytes, 1 gigabyte, and you can have 52 workers, and you have to send 52 gigabytes in 10 seconds. Okay. I think that Spark can help in all of these things, in the creation, the management, and in the network, and data sending. Okay. I found a library called TensorFlow on Spark. It was developed by the guys from Yahoo Hadoop team. Okay, they modified the TensorFlow to work with Spark. The cluster creation is done by Spark, and Spark runs TensorFlow. You don't have to worry about the IPs from the workers or the parameter server, etc. And they implemented RDMA, and the workers can write directly in memory to the parameter server, and this is very easy to migrate. And here is an example to run TensorFlow and to run TensorFlow in Spark. It seems the same, but no. Here it's a simple Python launch, but you have to launch it in every worker and every parameter server, and there you only have to run it in one time. Okay, and well, it's very easy in Spark. Okay, and this is some results. Sorry, I don't have more time. And any questions? Questions?
Can we see the result in this minute? So.
Okay. This is a very simple, the train of the Inception network. I think that is the version 1. And with one worker, to achieve an accuracy near to 0.773, I think, it spends 45 hours, and with 8 workers, you can achieve the same accuracy in 5 hours or 5 or 6 hours. And I'm sorry, I forget something. With this implementation, you can use the Spark RDDs inside TensorFlow. I think it's a very useful thing if you want to do some pre-processing in Spark and then go to TensorFlow.
Cool. Different question.
And which use cases? In which use cases you're basically applying this implementation on BSC or in your projects? Or?
In BSC now we are doing emotion recognition, and it's it's very hard to train with one machine with two GPUs, NVIDIA K80. It spends 120 hours, and in some experimental results we achieved the same accuracy with 8 hours. But in every run we have to modify all the scripts to run. When some worker dies, you have to cancel everything. You can't manage anything. The part of the manage is there isn't anything to manage the cluster of TensorFlow at the moment. Okay.
Thank you.
So next is Ilmira. She will present Y datasets in Spark. Let me put the full screen and pointer.
Hi. Where is the device? Where is the device?
Here.
Kind of working.
Not working.
Okay, you have seen all the presentation already. So I'm working in EuroCut, and we are working now with genomic data. We try to classify whether a person has a risk of complex diseases like diabetes, for example. So the typical partitioning in Spark is row-wise. So you have, if you want to calculate some statistics on one feature, this feature is split into partitions, and you calculate you make some operations, and then you collect the result using some action. But with wide data sets, this is kind of different. So the data we have is the single nucleotide polymorphism is variation in the DNA sequence in particular position. So the number of these positions can be very high. For us, it's 750k features, and the number of samples is only 1700. And this is the typical situation in genomic data sets, because you can't just sequence lots of people. 1,000 is already a big number. So imagine that you want to perform feature selection in this data set. So you want to, as the data is categorical, we use chi-squared feature selection. So you want to collect statistics from each feature comparing to the label. So if we use this traditional way of computing, for one column you will have parts of this column in each executor. So the computation is not really efficient. What I tried to do is just to transpose the data set, just a simple idea. And so you have all the columns, well, some columns, but all of the data from one column in one executor. And when the labels are broadcasted, and so the statistics is computed very fast. What I got now is 30 minutes, yes, 5.7 minutes for one computation of feature selection. When we multiply this on key-fold cross-validation, which can be, well, 10 for us, the advantage is huge, and if you perform lots of tests, well, the advantage is even bigger. So my idea was just to share my pain about wide data sets that using MLlib, the implemented things are not suitable for wide data sets. So even our dataset is not large, it's just like 5 gigabytes in file system and 10 when you load it. But it's already painful. For example, for random forest, it takes 73 hours to compute one set of parameters. And for random forest, it's kind of complicated to change, to transpose, and then work with transposed data set. And so that's what we are struggling now. That's it.
You said that your dataset is taking 73 hours to compute.
For random forest with all the features. When we don't pre-select features for one tree, because otherwise it doesn't work, because most of the features are not relevant.
In which infrastructure?
Sorry?
In which infrastructure?
Yeah, like 63 gigabytes and 32 cores, so it's not a big one, but that's what we have now.
Are you using sparse vectors for the features, or?
Well, yeah, if you use Emoli, I think they restrict you to use label points, which is label with vector. Why?
I was asking because we had the same use case,
Yeah.
and in our case, we let it run like for 4 days and it didn't finish.
Mm.
We had like 1 billion features for that. It was some taxi data set, and yeah, we started running something else.
Like what?
I will present.
Okay.
Don't spoil it.
Have you talked to the Spark community about this?
They have an open ticket for it, for random forest, for example, but it's not resolved yet. Well, thank you.
So next, Vlado. He will present. Let's see, Overkill Analytics. What's the pointer?
Hi, my name is Radu Kilom. I'm working at UBixAI. We're kind of focused on automating data science at scale. I'm working for 4 years now in the big data field, and yeah, I started on the Hadoop ecosystem, but we were kind of forced by price and performance issues to go into an early adoption of Spark. So my journey with Spark starts at version 0.6, so I had my fair share of out-of-memory exceptions. Okay, today I'm going to briefly present you Overkill Analytics and how are we using it. So I'm going to be short. Overkill Analytics is a data science philosophy for predictive modeling, and yeah, in theory, it favors volume over precision, effectiveness over elegance, and CPU over IQ. Some might call it like the brute force attack on data science, but like, what are they saying? Sorry. What are they saying? It's something like this. You want to have a large number of features, even though they are not complicated. You want to run your code like effective, like quick. Don't spend time on making it beautiful or like optimizing it, because you can use cheap servers in order to run it and make it fast. When you run with Overkill Analytics, it kind of implies that you use ensemble modeling techniques. Ensemble modeling refers to managing separate models as one big ensemble. This is not like a new term, and it actually underlies in popular machine learning algorithms like random forest. And the way that we are combining Overkill Analytics and ensemble modeling is that we are distributedly training scikit-learn models and as like separate models, and then we are seeing them as one big ensemble. So at the end, in order to get our final predictions, we have to use average or voting techniques. Okay, and how did we achieve this? We created the custom map partition transformation, which allows you to run runtime compiled Python scripts. Yeah, as you can see here, if you have a table like with multiple partitions, at the map partitions phase, you can run a Python script in which you can train a model on top of that data's partition and then save the model to disk. We've implemented primitives for model management and some cool features like custom data partitioning. So think of if you have data from multiple countries and you want to cluster by that country, so get the data from one country on one partition, yeah, you can do that, and then you will train your model on top of that country's data. Not sure if it is. The prediction part is similar to the training part. Like we do the same map partition transformation in which we execute the Python script that loads the model and predicts. And at the end, we have an average step which gives us the output table with predictions. Okay. Also, if you want, if you have all your code base in Scala, and if you want to do to run on top of a PySpark context, you can do some tricks. Like you can run from Scala a Python process. You can use the Java gateway to get a reference to the JVM context, and then wrap the JVM context into a PySpark context. And yeah, on top of that context, then you can run everything you want. And the nice thing is that on this context, you can see all the temporary tables that were registered on the JVM context. So how can you use that? Basically, if you have a data frame in Scala and you also want to see it in Spark, you can register it as a temp table, cache it, and then, in Python. And then from Python, you can see that data frame. Cool. Thank you. Questions?
You said that you implemented a Google partitioner?
Yeah, we actually wrapped up a map partition transformation.
I don't understand the point of doing that for routing by code. I don't test the point of it.
Okay, so what I'm saying is that here we kind of wrapped up a map partition transformation in which we allow you to give us a path for a Python script, and we'll execute that Python script for you on top of the data from each partition. And what I was saying about the example with the country data, so if you have data from several countries in one table and you want to train over a specific country's data a model, because this will all generate separate models, and maybe you want to repartition the data. We've implemented some code that does that for you. Okay.
So you never merge these models; they're just separate.
No. Yeah.
You don't need to merge.
Well, for random forest, not really. You can get similar accuracy with doing this instead of having one big model.
So one tree is on one partition. That's what that is.
Yes. We had the problem, we had the one union features, and we couldn't train it on Spark MLlib. So we've done this solution, and yeah, it works.
You do bugging in partition time?
Sorry?
You do bugging in partition time? Like sampling with replacement, or you don't do that?
No, we're not doing something. Because we can train on the whole data. This is really fast, really fast. Okay, thank you. Okay.
No, I can't.
2 minutes.
Okay.
They're gone. 2
no, no.
minutes that you can.
We're talking in front of you.
Okay, thank you.
Okay, some feedback. Who liked it? Who liked it? Yeah?
Yeah.
Who will talk the next time? Oh, come on. Roger, you will talk, right? Yeah. No, I think it was a good idea.
Yeah, I think it was a success. It was very interesting to see you like say, I would present these things. Also for me to see that some people was doing some kind of data sources before, and so I think it was a success.
Yeah.
It was really
Yeah.
nice to see.
Let's see. Next time, I think it was nice. So I hope when we do it again, you join us, prepare something. It was 5 minutes. I think it's a bit. It's quite a short, right? Well, Mark, you got 40 slides. But yeah, I think it was nice. So let's go to the kitchen and keep continuing the discussion and with beer and pizza. Cool.
Okay.
Thank you.